Question 14b. Without solving the equations, determine the number of distinct real roots for each of the following. Okay, so I am going to need to sketch the original curve. Okay, so our original curve was 3x cubed minus 5x squared plus x minus 6. And remember, our stationary points were 1/9, comma, minus 5.95. It's easier as a decimal now. And 1, comma, minus 7. Okay, so our sketch for this graph will look like this. Okay, it will come up through minus 6 to just slightly above. Then it's going to go back down to a height of minus 7. So we're going to get a graph that sort of is doing that. That's our original graph. Okay. So, part I. Notice that part I is our original graph moved up by 7 units, because we had a minus 6 there. Okay, everything else is the same apart from we had a minus 6 on our original, and now we've gone up to a plus 1. So our graph is going to move up 7 units, and if we move our graph up 7 units, this is what it's going to look like. It's going to go intersecting at 1, slightly higher. It's going to come right down and touch the graph axis there, and then go back up. Okay, so if the question said how many real roots have we got, that technically counts as 2 real roots, but they're equal. Okay, but the question has said how many distinct real roots have we got. Here's one, here's another one. The 2 that are the same don't count twice because it says distinct real roots. So that has 2 distinct real roots. Okay, our second one is more tricky. We've got a 6x cubed minus 10x squared plus 2x plus 1. So when you think about our original graph was a 3, a 5, a 1, and all of those coefficients have doubled. So let's say I write 2 lots of our original graph like this. That gives me 6x cubed minus 10x squared plus 2x, all that's fine, minus 12. But we want a plus 1. So actually what we need to do is add on 13. Okay. And then we get to our graph with a plus 1 on the end. So what that will mean is that our original graph has a 2 on the outside, which is a vertical stretch, scale factor 2, and then it's going to go up 13 units with that plus 13 on the end. Okay, so if we try and work out what this graph is going to look like if we stretch it vertically scale factor 2, okay, I can annotate this graph now. The minus 6 is going to stretch to minus 12. The minus 7 will stretch to minus 14. And we're going to have a graph that comes up, down to minus 14, and then we'll stretch all the way up, and it will actually intersect at the same point here, but I'm not so bothered about that because next we're going to lift that whole graph up 13 units. So the minus 12 is going to end up as a 1. The minus 14 is going to end up as a minus 1. So our graph is going to come up through the 1, slightly higher, then it dips down as far as our minus 1, because that was our minus 14 gone up 13, and then it's going to go back up. And then we can see we have 1, 2, 3 distinct real roots. So this second one would have 3 distinct real roots. This is a really tricky question because it doesn't really imply you have to think about transformations, but that's the way to solve it.